root are the root of the equations. Okay, so basically the roots here meaning is the roots of the characteristic equations. Basically that means that is the poles of the closed loop system. Okay, so that, let me first explain this. And what is a locus? Locus basically is with tracing the point. Okay, so here I try to, I know everyone's English is better than mine. So basically the locus is if we have a series of a point with tracing the trend of the point and we draw the line. So basically pretty much it's like curvilinear. Okay, so locus is a collection of the points. So basically here, the root locus basically is we are going to trace the change in the location of the root and we plot it. Okay. So now the reasons coming to why the root will be changed. How come the roots can be changed? So that is an issue, and you can imagine. So when we given characteristic equations, basically everything is determined, right? So how come the roots will be changed? Basically that implies for in these chapters, that implied this characteristic equations contains one parameters. Okay, so we study the characteristic equation that contains one parameters. Okay, so once we change these parameters, we want to know how the roots will be changed. And why we want to know how the roots will be changed? Because in previous sections, we realized in the in the complex plane, we know by telling the location of the roots, we can tell the stability of the system, right? So, for example, here is a stable, and here is marginally stable. So, this characteristic equation, basically, these equations has been, with a parameter we call the k. Okay. So, we want to determine the k value such that the root, location of the root, location of the poles of the closed loop system, or the location of the roots can be at the desired locations we want. Or we can say we want to determine the range of the k such that the system is stable. So basically in these chapters, in this module, our focus will be on varying the value of the k and to find the corresponding root. That's it. Okay, and the value of the k can be changed. There are so many options for value of the k. So if we do the intuitive way, and that is not so systematic, that is not so scientific. So that reason, in this way, we want to develop a spatial method, and hopefully that allow us to systematically plot the locus of the roots for every possible value of the k. So that is our goal of learning in these chapters. Are we okay? Okay. So before I really dig into the details, that's the big pictures. And you might ask me, what is the role of the k plate here? So basically, k is one of the parameters. One parameter that can going to categorize the characteristic equations. So you may visualize k is a certain constant controller gain. Okay, so k can be a controller gain. For example, k can be, say, when you design your systems, so if this is a mass, if this is a damper, if this is the spring, so k could be here. You are designing a vibration system to determine the value of the k, and such that the dynamics can be as desired. So that means you will be able to formulate the Gaussian equation for this, and you'll be able to do the Laplace transform. and you'll be able to develop the characteristic equation in terms of the parameter k. From there, you'll be able to symbiotically solve for the roots, and you can label the roots. For example, if you wish this system have the damping ratio, say how much, or the vibration oscillation in terms of how much frequencies you want, basically that corresponding is a particular location of the poles here, for example here. So under this situation, that should have a corresponding to a very particular value of the k, make this happen. Okay? So in this case, in these chapters, the first scope is we want to learn a systematic method allow us to plot all the possible value of the roots in terms of by changing the value of k. That is the first scope we want to study. The second one is we want to do, using this method, do controller design, which means in the second scope is we want to learn how to choose an appropriate value of the k and such that the roots will be go to where we want. So that's the two options here. So basically in this module we will gradually kick into the controller design. Okay, and this module will take about a few weeks. In my estimation, probably 2 to 3 weeks, because that pretty much involve, the methods are pretty much involved. Okay? So, any questions? Okay, so we can go to the new sections.